Welcome to the Foundations module. In this video, we are going to look at the single biggest idea behind FastAPI, the fact that ordinary Python type hints do an extraordinary amount of work for you. By the end, you will understand exactly why FastAPI leans so hard on them, and how that decision shapes everything else in the framework. Before FastAPI, handling a web request in Python meant a lot of manual plumbing. You would pull a value out of the query string, cast it from string to integer, check whether it is in range, and then separately document all of that in a docstring or a spec file. Every one of those steps is a place where the code and the docs can drift apart, and your editor has no idea what shape the data is supposed to be. Here is a way to picture it. Think of a paper form at a government counter. Each field has a printed label that says what kind of data it expects. The agent at the counter checks the labels before handing the form to the back office. You never have to write a rule that says, reject non-numeric ages, because the label already declares it. Type hints play exactly that role in FastAPI. They are the printed labels, and FastAPI is the agent who enforces them. Let us name the pieces. A type hint is the colon annotation you write after a parameter name, like item_id int. A Pydantic model is a class that extends base model, where every attribute has a type hint. FastAPI inspects your function signatures when the application starts up, builds validation rules from the hints, and generates an open API schema from those same rules. You write the shape of your data once and three things, validation, coercion, and documentation, follow for free. Let us walk through this file top to bottom. We import FastAPI and HTTP exception from FastAPI and base model from Pydantic, then create the app instance. The item class extends base model. Its three fields each carry a type hint, so Pydantic knows name must be a string, price, a float, and in underscore stock, a bool that defaults to true. In the read_item function, item_id int in the path tells FastAPI to pull that segment from the URL and convert it to an integer. If the caller sends a non-numeric value, FastAPI rejects the request with a 422 before your function even runs. The optional q, str or none becomes a query parameter with no extra code. The return type annotation, item, lets FastAPI serialize and validate the outgoing response. In create_item, annotating the item parameter with the Pydantic model type tells FastAPI to pass the entire JSON request body into that model, validating every field. All of this validation, coercion, and the open API schema at /docs comes from those annotations alone. Here is the flow under the hood. When your application starts, FastAPI walks every route function using Python's inspect module and reads the annotations. It builds a Pydantic model for that route's inputs and a JSON schema for the open API spec. When a real request arrives, FastAPI runs the incoming data through those validators, coerces types, turning the string 42 into the integer 42, for example, and only then calls your function with clean typed values. The trade-off is that you're coupling your code to Pydantic and to FastAPI's reflection mechanism, so pure library code or very simple scripts do not need this layer. Knowing when this pattern pays off is just as important as knowing how it works. Reach for typed annotations on every public endpoint. That is precisely the context FastAPI was designed for. If your team also runs a static type checker like mypy, the same hints give you editor auto-completion and compile time catches. On the other hand, do not annotate internal utility functions with Pydantic models, just because you can plain Python is clearer there. And watch out for two common traps. Annotating parameters as any silences all validation, and returning a raw dict instead of a typed model means, FastAPI, I cannot enforce your response shape. To wrap up, FastAPI treats your type hints not as comments for humans but as executable contracts for the framework. Write the shape of your data once in a function signature or a Pydantic model, and you automatically get input validation, type coercion, and a live open API document. That is the core promise of the framework, and every other feature we cover in this course builds on top of it.